Okay, students. Now in the angle modulation, now you know the amplitude frequency modulation, phase modulations, and phase deviation and frequency deviation, right? Now I am writing here angle deviations. Now you just see here FM. Now first we'll see in frequency modulation. What is the instantaneous angle or augment in frequency modulation? In frequency modulation, instantaneous angle is 2 pi fct plus 2 pi kf integral m of t dt. Am I not? Now this is frequency modulation, instantaneous angle or augment. Now this you further simplify theta I, which is equal to 2 pi fct plus beta sine 2 pi fm into t. Am I not? Now what we want? We want a frequency modulation. Generally, what type of deviation in the frequency modulation? In frequency modulation, frequency deviation. But what I am asking is phase deviation. Phase deviation in frequency modulation. How it is possible? In frequency modulation, frequency deviation, but I am writing phase deviation. Phase deviation in frequency modulation. So what should be the phase deviation in frequency modulation? We have to be answered. Actually, in frequency modulation, only frequency deviation, but frequency modulation comes under the category of angle modulation, right? So means both when phase is changes and frequency changes, angle is changes. Therefore, now I want to find the phase deviation. So you know that now omega, which is equal to theta by t radians per second. Now when the phase angle theta, which is equal to omega into t, or theta, which is equal to 2 pi f into t. So now you see here, this is theta I, this is 2 pi f omega c into t, means this is angle itself, beta sine 2 pi fm into t. Now the deviation, this is theta I, which is equal to theta c plus beta into sine 2 pi fm into t. Now the deviation, phase deviation, phase change, theta I minus theta c, which is equal to beta into sine 2 pi fmt. Now the maximum phase change is nothing but the phase deviation, theta I minus theta c. The maximum phase change is nothing but the phase deviation, now which is nothing but beta. Sine value is 1. So what is beta? Beta, which is equal to kf into am by fm. Is it right or not? Now this is the phase deviation in frequency modulation. This is the phase deviation. The phase deviation is nothing but the modulation index beta now in fm. So this is the phase deviation in frequency modulation. Now see here, and what about the frequency deviation? The frequency deviation is generally kf into am. This is general. Now similarly, can we find the same thing? Frequency deviation. Frequency deviation in PM. Generally, there is a phase deviation in phase modulation, frequency deviation in frequency modulation, but I am writing reverse. Okay, just concentrate. So, what is the angle? the angle or argument in phase modulation theta I, which is equal to 2 pi fct plus kp into m of t. Is it right or no? Now this is nothing but, can I write like this? Now d theta I by dt, which is equal to 2 pi fc plus kp into d by dt of m of t. Now d theta by di, which is equal to omega I, which is equal to 2 pi fc plus kp into d by dt of m of t. Now see here, now this is 2 pi fi, which is equal to 2 pi fc plus kp into d by dt of m of t. 2 pi cancel, fi, which is equal to fc plus kp by 2 pi into d by dt of m of t. So I want a frequency change. What is the frequency change? The frequency change fi minus fc, which is equal to kp by 2 pi into d by dt of m of t. Now what is the maximum frequency change? fi minus fc. The maximum frequency change is nothing but the frequency deviation in phase modulation kp by 2 pi kp by 2 pi d by dt of m of t. Now the maximum frequency change fi minus fc, which is equal to kp by 2 pi into am 2 pi fm into differentiation of cos is sin 2 pi fm into t. 2 pi cancel. Therefore, the frequency deviation in phase modulation is kp am fm. Maximum value of this is 1. This is the frequency deviation in phase modulation, right? But what is the phase deviation? What is the actual phase deviation? The actual phase deviation, which is nothing but kp into am. Now the phase deviation is depends upon amplitude of the message signal, but the frequency deviation is also depends upon the frequency of the message signal in phase modulation. Now here the actual frequency deviation is depends upon the amplitude of the message signal, but the phase deviation also depends upon the frequency of the message signal. Clear now? Now this is the phase deviation in frequency modulation and frequency deviation in phase modulation. Okay, so therefore now it depends upon the frequency deviation is depends upon amplitude of the message signal is depends upon frequency of the message signal. Now here the phase deviation depends upon amplitude of the message signal and is also depends upon frequency of the message signal. Okay, now these are the sometimes you confuse. Okay, in the question frequency deviation in frequency modulation, phase deviation in phase modulation, but reverse, frequency deviation in phase modulation, phase deviation in frequency modulation. If any question is related to that, so remember these formulas and according to that you move further. Okay, note down. Now you know the amplitude modulation, frequency modulation, phase modulation. Now we'll see the comparison. Comparison of analog modulation techniques. Type of modulation, amplitude modulation, now first we will see with modulation index. Now in AM, the modulation index mu, which is equal to Ka into AM. Now in FM, modulation index beta, which is equal to Kf into AM by FM. Now in PM, modulation index beta, which is equal to Kp into AM. So with respect to modulation index, what should be the common points? Okay, right, like that we can continue. So now the point is, all the modulation index are depends upon amplitude of the message signal. Is it right or not? All the modulation index are depends upon amplitude of the message signal. All the modulation index are depends upon amplitude of the message signal. All the modulation index are depends upon amplitude of the message signal. And modulation index in FM also depends upon frequency of the message signal. Now with respect to modulation index, then this should be the common point. Okay, note down. Clear or not? Now deviations. The amplitude deviation what is the amplitude deviation? The amplitude deviation is AC into mu, which is equal to AC into Ka into AM. Right? So I think amplitude deviation, are you got it or not? Amplitude of the carrier before modulation is AC. What is the maximum amplitude of the carrier after AM modulation? AC plus AC into mu. What is the minimum amplitude of the carrier after AM modulation? AC minus AC into mu. Before modulation, this is before modulation. These two are after modulation. After modulation. Now, before modulation, amplitude of the carrier is AC. After modulation, amplitude of the carrier is AC, but it is deviated by an amount of AC into mu. It is deviated by an amount of AC into mu. Now, this is nothing but amplitude deviation, because amplitude is changing. How much is changing is nothing but the deviation. Now, this is amplitude deviation, which is equal to AC into mu in amplitude modulation. Okay, in amplitude modulation. Next, in frequency modulation, obviously frequency deviation. Now, the frequency deviation in frequency modulation, which is Kf into AM. Now, the phase deviation in phase modulation, which is Kp into AM. You know that all the deviations must and should depends upon amplitude of the message signal. All the deviations, all the deviations are depends upon amplitude of the message signal. All the deviations must and should depends upon amplitude of the message signal. AM, AM, AM. Now, with respect to deviations, now this is the point. Bandwidth. The bandwidth of AM, which is 2 omega or 2 FM. The bandwidth of FM is 2 into beta plus 1 into FM. The bandwidth of PM is same, 2 into beta plus 1 into FM. So what should we observe here? All the modulation techniques, all the bandwidths are depends upon frequency of the message signal. All the bandwidths are depends upon frequency of the message signal. All the bandwidths are depends upon frequency of the message signal. And what is the second point you observed? In FM and PM, the bandwidth also depends upon modulation index. In AM, bandwidth is independent of modulation index. In AM, the modulation index is used for demodulating the AM signal, because here envelope detector is used. But in FM and PM, the modulation index FM and PM, the modulation index is used for spectral analysis. Note down. Here, now total power. Now the total power in AM, which is equal to PC into 1 plus mu square by 2. Now the total power in FM is unmodulated carrier power. The total power in PM is also the unmodulated carrier power. So in FM and PM, the power is independent of modulation index. In AM, the power is depends upon modulation index. See here, in FM and PM, the power is independent of modulation index, but in AM the power is depends upon modulation index. Next, AM amplitude modulation requires more power because information itself in the form of amplitude. Amplitude modulation is the amplitude of the carrier is continuously changing. So, FM and PM, FM and PM requires less power because there is envelope is not changing, carrier before modulation and carrier after modulation is same, therefore the total power required to transmit the FM and PM signal is same as that of unmodulated carrier, requires less power. AM requires more power. Now this is a comparison with respect to powers. Okay. Next, power efficiency. Power efficiency or modulation efficiency. Power efficiency or modulation efficiency. What is the power efficiency or modulation efficiency? The power efficiency or modulation efficiency is mu square by 2 plus mu square out of total power. How much power is carried by sidebands? So, the maximum efficiency is 33.33% in the case of AM. Now the power efficiency, which is equal to out of total power, how much power is carried by sidebands, and the power efficiency is 100% for beta equal to 2.4, 5.5, 8.6, 11.8. The power efficiency, which is equal to how much power is carried by sidebands, and here is also the power efficiency is 100% for beta equal to 2.4, 5.5, 8.6, 11.8. If this table is available, you can answer for any problems. Now, linearity. You already know that amplitude modulation is a non-linear modulation. This is the non-linear. This is also non-linear modulation. This is also non-linear modulation. Is it right or not? Now this is a non-linear modulation because you already know how to check the non-linearity. Okay, non-linear. Now one table which is sufficient now for everything. See, all problems are all the formulas I just write it in one single table now, which is useful to you for any competitive examination. Okay, and just FM, PM. What about the noise effect? Now we are not doing the noise analysis, but you are in a position to say the noise behavior. How you can say the noise behavior is how much in AM, how much in FM, how much in PM? How you can identify? Effect of noise in AM is very high, is very less. Compare with AM. So anyway, okay. So I just give the idea about how to find that. Now see here. In AM, effect of noise is more because the information itself in the form of amplitude. If any unwanted signal is coming, first it will destroy the strength. Am I not? First it will affect the strength. But what is the strength? The strength is nothing but amplitude. But where is your actual information? Your actual information is available in the amplitude. Therefore, your information will be disturbed when the effect of noise, whenever the noise is affected, the modulation technique. Here, the information, any modulation technique, the noise is affected. One common point. First, the noise is coming and directly attack the strength. Strength is nothing but amplitude. So what happened in AM? In AM, the noise is coming and directly attack the amplitude, directly attack the strength. But in amplitude modulation, the information is already available in the form of strength, in the form of amplitude. Therefore, the loss is more, distortion is more, and your information is lost. Therefore, effect of noise is more. So what we can say that effect of noise is more, therefore, which means that such that signal to noise ratio is very poor, very less. For a best system, the signal to noise ratio should be as high as possible. Okay, now come to here. In FM and PM, effect of noise is less because the information is in terms of frequency, not in the form of amplitude. So again, take a same case. Noise is coming and affect the strength. Whenever the noise that is directly attack the amplitude. But if it is attack the amplitude, in frequency modulation and phase modulation, information is not in the form of amplitude, information is in terms of frequency, am I not? So frequency modulation means, now this is frequency deviation, phase modulation means phase, therefore information in the form of frequency and phase, but not in the form of amplitude. So the noise is coming and directly attack the strength, directly attack the amplitude, but your information is not in terms of amplitude, because this is not an amplitude modulation, this is frequency modulation and phase modulation. Therefore your frequency modulation information is available in the terms of frequency, phase modulation information is available in the form of phases. Okay, so even if amplitude is affected, not a problem. Therefore, such that what we conclude, such that signal to noise ratio is high, is very, very high in FM, and signal to noise ratio is high in PM. So the best one with respect to, anyway, when we will see in detail when we go for the noise analysis, but FM and PM both envelope is same, even that the signal to noise ratio is very, very high in FM. So with respect to noise, the best one in analog modulation techniques is nothing but FM. First one is FM. Okay, now the next one is PM, and AM is not at all comparable with FM and PM. Okay, so PM signal to noise ratio is high, but in FM signal to noise ratio is very, 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 very high, and it is not at all a comparable with AM. Okay, AM signal to noise ratio, FM signal to noise ratio is a large gap, large deviation. It is very, very high compared with AM. Therefore, we never prefer AM. That's why nowadays you are not listening AM radio, you are listening FM radio. Okay, so for for audio signal transmission, FM and PM, FM and AM is preferred, but FM is the best one now because with respect to noise. Okay, now in video signal transmission, VSB. Okay, voice signal transmission, SSB. Okay, so now the audio, for transmission of audio, so you tell me which one is the best among these three analog modulation techniques. Now among these three analog modulation techniques, the best one for transmission of an audio signal is FM, because noise is very, very less. Okay, very, very less. Even bandwidth is more, but it is preferable because noise is less. No doubt. And with respect to bandwidth also, here one point I missed. AM requires less bandwidth. FM and PM requires more bandwidth, because this is wideband FM and wideband PM. So a wide range of frequencies. So it requires, to transmit an FM signal and PM signal, we require more bandwidth, but to transmit AM signal requires less bandwidth. FM and PM requires more bandwidth. Clear or not? So almost, see the students, this is the last point in analog modulation techniques. Now if you see this table, Now total amplitude modulation, frequency modulation, phase modulation, everything which is available, and any question in those amplitude modulation, frequency modulation, phase modulation, if you just look up this table, definitely you can able to solve that particular question. Okay, now note down this. Clear? Now this is very useful. This table which is very useful to you for answering any objective question or any problems. Now see here, input, phase modulator, input is a message signal, phase modulator, then you can get a PM signal, right? Now this is the input signal, m of t is going for an integrator, then it is applied to frequency modulator, you can get PM signal. Okay, no doubt. Oh, sorry, this is differentiation, right? D by dt of m of t. Now, here frequency modulator, output is FM signal. Now input is message signal. Means now this is the message signal and integration of m of t, and this you apply to phase modulator, then you can get FM signal.